Center of gravity. The center of gravity of a rigid body is the point at which its weight can be considered to be acting when the torque due to the weight is being calculated. So, when you're calculating the torque on an object based on the object's weight, you can treat the weight of the object as if it's all at one point, the center of gravity. Remember that a torque is the result of a force, and the weight of an object is a force. The object acts as if all its weight is at this point. The center of gravity for a symmetrically shaped object, whose weight is distributed uniformly, is located at the center of the object, even if the center of the object is not within the object itself. For a group of objects, you can find a collective center of gravity, a center of gravity for the whole group. Let's say this board and this block are moving together around this axis of rotation. Let's find the sum of the torques on the objects due to their weights. Remember, torque is the magnitude of force times the lever arm. So if the board is object 1 and the block is object 2, the sum of the torques is F1 L1 plus F2 L2. Force 1 is the weight of object 1, and force 2 is the weight of object 2. Since the board and the block are each symmetric shapes, their individual centers of gravity are at their respective centers. This is where the force of weight is considered to act. The lever arm for each weight, then, is the distance from the rotation axis to each object center. We'll call these x1 and x2. Substituting in these for our force and lever arm terms, we get this expression for the sum of the torques. You can also find the sum of the torques by treating the system as one object, so that the combined weight is located at the collective center of gravity. For this case, our force would be equal to the combined weight of the two objects, and our lever arm would be at a position xcg for the position of the center of gravity. Plugging these in for the sum of the torques gives us this expression. Both of these are true, which means that they are equal to each other. We can solve this for the position of the center of gravity in order to get an expression for calculating it. You'll notice that this expression is similar to the expression for center of mass. Also similar to that expression, if you add more objects to your system, you just include more terms to the expression. In fact, at the same location on the Earth, where the value of g is the same for all of the objects in question, the location of the center of gravity is the same as the location of the center of mass.